insert some elements into the B tree. F, S, Q, K, C, L, H, T, V, W, M, R, N, P, A, B, X, Y, D, Z, E. Okay, suppose these are the elements to be inserted. So we know how to start with. The first step is to create an empty tree. I hope you all remember that. The first thing is that create BTree create. So there we'll create x equal to allocate node, then x dot leaf equal to 2. So it will actually allocate one node, then x dot leaf equal to true. We are setting it as a leaf node, that is the first node. Then x dot n is equal to 0, number of elements are 0, then disk right of x we can write, then t dot root is equal to x. Okay, now x will be the root of the tree. Okay, this is how we create one tree. Then after creating this one node, we can insert. Okay, so for that we use BTree insert procedure. There you are supplying this tree and the key value k, and you are checking the root, and you are checking whether the root is full. If root is full, then you need to invoke a BTree split child operation. Otherwise you can directly invoke BTree insert non-full r comma k. Okay, and non-full r comma k, what will that do? It will check if it is a leaf node. Then if it is a leaf node, then it will the specialty of leaf node is that we can insert our key value into that node. Okay, so we need to make a space for that new value. For that we are shifting this key values one position and we are inserting the value. Okay, and that is returned to the disk. This is how we can insert a node. Okay, so initially f is to be inserted, f. So according to the procedure we can create a node and we can, that is the single node, so we can copy f, okay, or write f to that node. Then the next input is s. So what will happen when s is the input? You can again place s into this. Before that I need to supply one more thing, that is what is value of 2. Suppose t is equal to 2. What is t? That is the minimum degree of this tree. Okay, B tree. So t is equal to 2, which means you can have a maximum of 2t minus 1, that is 3 keys in one node. Okay, if t is equal to 2, then you can have 3 keys in one node, which means it can have 4 children nodes. Okay, so f is inserted, then s is inserted, then you have q. So that is again inserted in this node. So what will happen? You have f, then q followed by s. Okay, f, q, s. Okay, now your input is k. When k comes, again it will find out a room for this k. Okay, so when we read this first node, it will check whether what is number of this is x. So what is x dot n? If x dot n is equal to 2t minus 1, it will invoke a split. split child operation. So to split this, it is a root node. So to split a root node, what will happen? It will first allocate one node and it will make this as child of this one. Okay, that is like this, and then we will find out the median and that will go to the root. So what will happen? Then after that Q will come to the root. Then it has two children nodes, one is F and the second one is S. Okay. And we need to insert K. Then Q, F, then K, S. Okay, this is how this follows. Then the next input is C. So to insert C, you have Q and C will come to this point. Okay, C, F, K, and you have S here. Okay, next input is L. You need to insert L. So how will you insert L? When L comes, you will start from Q. Then you have reached a node CFK, that is a full node. So you need to split that full node. Okay. So how will you split this? You will find out the median, and that is moved to its parent. So this F will come to the root, FQ, and this is C. Okay. And we have K, then S. Remember, when there are two key values, it will have three children nodes, and we need to insert L. So which means L can be inserted into this node. Okay, that is L. Then you need to insert H. So inserting H. So what will happen? Where will H go? H will go to the left of K. So F, Q, and you have C here, and here you have KL. So you can insert H, K, L. Okay, H, K, L, and you have S here. Okay, now you have T. T is the next input. So when T comes, S, T. So S, T will go to the right of S. So you have F, Q, then it says C, then H, K, L, then S, T. Okay, S, T. Then the next input is, after T you have V. So V needs to be inserted to this node. Okay, V should go to this STU. Okay, so you have F, Q, then F has a C, then HKL and ST. STV. Okay, so after inserting V, you will get less. Then you need to insert W. Okay, next step is to insert W. So where will W go? STUVW. Okay, that needs to be inserted to this. So we'll start from FQ. Okay, we'll start from FQ and we'll reach this position. Okay, that's what the BTree insert procedure says. Okay, so we'll move to, if it is not if it is, we are checking whether if it is a leaf node. Okay, if it is a leaf node, we will insert, else we will check the exact position for that, that is I greater than or equal to 1 and k less than x dot key I, and we are decrementing the value of I. So, we will find out a position for this key, and we will increment this I plus 1 that we saw here. It will come here, but we need to go to this child. So, that is why we are incrementing this value, and we are reading that child node from, that is ith child node from the disk, and we are checking whether that is a full node. If it is a full node, then we will invoke a BTree split child operation, and then we will find out the exact position. Okay, so that is what the algorithm says. So, we'll find out a position, and we know that that is here because W is greater than Q. So, it will find out this, or it will read this node from the disk, and when we check this, it is a full node. So, we need to split this. Okay. So, how can we split this? We will find out the median, that is T. Okay. So, this I think okay, this will accommodate the 3 values. So, F, Q and T, F, Q and T. And what about the children nodes? We have C here, then we have H, K, L, and after this we have S, and to the right of this we have V. Okay, and we know W is to be inserted. So, W will come to this position. Okay. Now, we need to insert M. Okay, where will M go? L, H, K, L, M. Okay, so this is a node where we can insert M. So, we will start from the root, that is the procedure. So, when we start from the root, we come to know that the root is a full node. So, we will split root first. So, how can we split root? Again we will make an empty node, and we will make this as a child of this node, and the median will be given to that empty node. So, Q will come to here, and we have F and T. Okay. Now, this F has left child C, and what will happen to this child, that is Q, that is in between F and Q, that is greater than F and less than Q. So, that will come to this position. Okay. So, H, K, L, this is T. Now, T has left child S and a right child V, W. Okay. So, this is for inserting M, and this will lead to M needs to be inserted to this node. So, that is a full node. So, again we need to split. So, Q is here, then left child of Q is F, right child of Q is T. Now, F has okay, this node needs to be split. Okay. So, which element will come? K will come to this node. Okay. So, we have C to the left of F, and we have H in between F and K, and L, M here, L, M, and the left of S, T we have S, and to the right of T we have VW. Here remember one thing, that all the leaf nodes should always be at the same level. Okay, that condition is preserved. So M is inserted. Then R. Okay, R. So where will R go? Q, R. Okay, so R will come to the left of this S, that is non-full node. So it is safe to add Q. Q has F and K. Now to the right of it we have T, and we have C, H and L, M, and to the left of this we have R, S, and to the right of this we have V, W. Okay, R is inserted. Which is next? After R we have N, P, A. N. So where will N go? L, M. So to the right of this M. So that is safe to add. So we have Q, then F, K, then T, and this has left side C and H, then L, M. Then we have L, M, N. L, M, N. Now we have R, S and V, W. N, then P. We need to insert P. So where will this P go? P will come to this node. Okay, P needs to be inserted to this node, but this is already a full node. So that is a leaf node and it is full. So we will take M to this tree, this node. Okay, that is FKM. So we need to insert P. Root of this tree is Q. We have F, K, M. Then we have, what is it? T. T has RS and VW, and we need to insert P. So to the left of S we have C, and to the right of this we have H, I think. Then to the right of K we have L, and to the right of this we have N, P. P will be inserted, N, P. Okay, now we need to insert A. How can we insert A? A will go to left of this, so that is safe to add. So Q here, then we have F, K, M and T. So T has RS and VW. Then to the left of F we have A, C, and here we have H, here we have L, and here we have N, P. Okay, so after A we need to insert B. Okay, note like this. When we are trying to insert A is not inserted here because this is a full node. Okay, so we need to split this first. So that is, when we split this, K will go to the root. So we have Q, KQ, K is here, then Q. So to the left of K we have F, and to the right of K we have M, and to the right of Q we have T, and here we have C, and we have H. To the left of M we have L, and to the right of M we have NP, and here we have RS, and here we have VW. Now we can insert A. Okay, A is inserted here. Next input is B. Insert B. B will go to this node. Okay, so we have KQ, then F, M, then T, and A, B, C, then we have H here, then L, and NP. Now we have RS and VW. Okay, after B, X by D is a D. We need to insert X. X will go to WX. Okay, so after inserting X, we have KQ, we have F, M, T, and to the left of this we have A, B, C. To the right of this we have H, and here we have L and NP. L and NP. So here we have RS and VWX. Is that right? VWX. Okay. Now we need to insert Y. Okay. Y. Insert Y. So Y should come to here. Y is the next, right? Yes, Y. So Y will come to here, but that is a full node. So we will move W to its parent. So we have KQ and F is here, F, M, then this will get T and W. Okay, F has A, B, C, then it has H also, then L is here, NP, and we have RS, then in between these two we have V, and to the right of this we have X, Y when Y comes. Okay, next input is X, Y, D, D, that is inputting D. So where will D go? D will come to the right of C. So B will move to F. Okay, so we have KQ and F has one more key value, that is BF. Then we have M here, then TW, then to the left of this we have A, and right of this we have C, and now we can insert D here. Okay, and to the right of this we have H, so here we have L and NP. Now we have RS, then B, and we have XY. Okay, that is when inserting E. Then Z and E. Where will we insert Z? Here. Okay, so that can be done without any modification. Z. So we can insert. So inserting Z. Z will come to this position. Okay, now inserting E. Insert E. DE. So it will come to this position. Okay, so KQ, BF, M, then TW, A, then we have C, D, E. To the right of this we have H, to the left of this we have L, to the right of this we have NP. So here we have RS, P, and X, Y, Z. Okay, this is how insertion happens. Okay, we will see analysis of this algorithm, analysis of all this algorithm in the next class.